All right, good afternoon, everybody. We are going to go ahead and get started. Thank you all for joining us this afternoon. I'm Dennis Regas from Riverside County Office of Education. I'm one of the four math team members, administrators at Riverside County Office of Ed. I've also got one of my colleagues here with us today. I'll let her introduce herself. I think she's there.
Hi, yeah, I was muted. I do that often. Hi, everyone. I am Karen Akins. I am also one of the math administrators for Riverside County Office of Education. Thanks for joining us today.
All right, so today I want a little just FYI, we are recording the session today just so we can share it out with those that were unable to be with us today. We're going to be recording the main room, so when you're in breakout rooms, there won't be any recording going on in there. But if you could mute yourselves and feel free to use the chat to ask questions and things like that. So our goal today, we're going to be talking about a couple of number sense routines that we hope you can utilize in your classrooms to help further develop student number sense in grades TK through 5. So with that, there's more resources you can get to as well through our Region 10 Math Network. Region 10, if you don't know, is Riverside, San Bernardino, Inyo, and Mono counties. It's a pretty big region, takes up about 25% of the land area in California. So we do have a website there, and this presentation will be sent out to you, so you don't have to try to write any of this down right now. We'll send it out this afternoon or tomorrow morning. But there are more videos on there and things like that that we've curated to help further conversation. So a little bit about myself. This is one of my favorite activities to do with students and adults, and so I wanted to share it with all of you. It's from UCubed. It's called I Am a Mathematician. And so basically this is all about me. You know, I'm a father and a husband. I love hiking. I love learning. I really do believe that mathematics should be joyful and more of exploration than learning arithmetic. On top of all of that, I'm also a mathematician. So, but it is not the only thing I am. So one of the ideas that we shared in the intro video to this is a quote by Christine Tondevald, and she's several times I've seen her speak, and she oftentimes says that number sense is caught, not taught. And that's one of the things that makes developing number sense in children rather difficult, because it relies a lot on their own experiences, the experiences they have in class. And sometimes it's not always the experiences they're having during the math lesson, because their ideas about numbers and the relationships and the connections they make are going to be the things that help to develop their number sense over time. And so recently, listening to Christine Tondevald talk, she's actually gone a little bit further now to say that kind of math is caught and not taught. And we definitely can teach algorithms, and we can definitely teach arithmetic to students. But a lot of those relationships that we may see as adults, or maybe we don't see so much. I know I didn't until the shifts in teaching that happened over the last decade or so. I really wish I would have learned math the way I'm advocating for it to be taught now. And I wish I would have seen a lot more of those connections. But while there are aspects of math that can be taught, there is a huge portion of it that really has to be experienced, and we have to make sense of ourselves in order to have a deep understanding of it. So there's her website's down there at the bottom. She refers to herself as the recovering traditionalist if you're not familiar with her work. But she has a lot of resources available about number sense, subitizing, things like that help our kids in TK through 5 develop a deeper number sense. So what I wanted to do first with everybody is a notice and wonder. So we have a data visualization here. And what I'd like to do is ask you to just first think about, what do you notice about this picture? And what I want to do is something we're going to call a group return. So type something into the chat that you notice about it, but don't hit return yet. So type into the chat something you notice about the image, and And then in a moment, we're going to hit return as a group, and it's going to populate that chat. We are going to be sharing the presentation with everybody. It'll go out after the session. Okay, so if you've got something typed into the chat, go ahead and hit return. You see fraction bars, Cuisenaire rods, a number line, missing parts. Each number is building on what's already there. So ways to break up multiplication. The numbers 1 through 10 are shown in different ways. Awesome. Okay. So each cube has a value. The number represents lengths. Okay, awesome. So now we're going to take that a step further. And what do you still wonder about it? What are the questions you have about it? So again, think about that for a second, and then we'll drop that in the chat. And in a moment, I'll tell you to hit return, and we can see those. All right, so go ahead. What do you wonder? Go ahead and hit return. Let's see what those say. Let's see, it says, do the colors mean something? What is this for? What would students think about this? Is there a pattern that goes from small to larger? Why didn't I see it before? The cubes correspond to the staircase of linker cubes. Yes, the Cuisenaire rods down at the bottom. Excellent. Okay. So just as this activity, I'm not sure how many of you are familiar with Notice and Wonder. This is a data visualization from Data Talks on YouCubed, which is a newer piece of information that YouCubed has put out about data science and data literacy. So this was one of the visualizations that they provided. But just as you all had a chance to kind of notice things about the picture and wonder, ask questions about it, these same activities do help build number sense for students, because it actually helps them to articulate their thinking and to make connections to their thinking and other students' thinking when that's shared out publicly. So notice and wonders that are based in data or mathematics oftentimes can help to build students' number sense by giving them those experiences to kind of think through their thinking about something and their classmates thinking about something. Okay, so as we move forward here, we want to talk very briefly, and then we're going to get into the two routines we're going to talk about today, is what number sense is. So number sense is about understanding. It's a very elusive topic. You know, you look it up if you look up number sense online or Google it or look through our frameworks and standards, it's not something that is easily definable, you know, in a very, I think all of us have an idea of what it is and could probably put into words what we think, you know, number sense is, but it's not concrete, I think, for a lot of people. And it means a lot of different things in different situations. So we also know that it can be easily supported, and it's very important that students use fingers and models and pictures and all sorts of materials as they're interacting with mathematics to help build their number sense. So it develops when students communicate their understanding, and we know it's a foundational building block for future mathematics and opportunities in life. You know, the kids that seem to pick up fluency with facts faster and just a deeper understanding later on of maybe ratios and proportions and rate in middle school, fractions. These are usually students that have a deeper number sense, a deeper understanding of those patterns and connections and relationships between numbers. And finally, it is also it's developed through experiences with quantities and with relationships. So providing those experiences for students to make sense of mathematics themselves and use manipulatives and drawings to communicate their thinking are all experiences that are going to help develop their number sense, their understanding of place value and different topics. So what number sense is not, it can't be measured by the instant recall of facts. A student that knows their math facts, whether addition, subtraction, multiplication, division quickly, does not necessarily have a strong number sense as well. It's not something that can be directly taught. We can provide a lot of experiences and a lot of facilitating and working with mathematics for students, which is in a sense teaching it, but it's not something that we can directly teach in the sense of direct instruction. And then finally, it's not something that can be measured with single answers or multiple choice assessments, those types of things. It's to really understand whether students have a grasp and a solid number sense. It takes really diving into their thinking and getting to understand their thought process about a problem. So one of the ways that we can do that is getting kids to share their thinking. So we are going to drop into breakout rooms in a minute, but first, if you did see the intro video, we did talk about this routine, ways to make or how many ways for a little bit, but it's really a number sense routine that helps kids to make connections, helps them think about problems differently and see relationships between the way they think about it and the way their classmates think about it. So I do like this routine because it translates very well to a synchronous or asynchronous environment. So the idea here is, and this template is something you can use, just change the number in the middle. But the idea is that we would, on poster paper or in a Google Classroom on a slide, create something that looks like this in a sense, maybe just the number in the middle. But we've got 3.5, and we're going to ask students, how can you make 3.5? Like, what are the ways that you can think of making up 3.5? So what I'd like you guys to do, I'd like everybody to do, is just think about that for a second. What's one way you could come up with making 3.5? And type that into the chat. And go ahead and hit return. You can just start populating the chat. If you can think of more than one way, go for it. So we see 7/2, 7/2, 7 times 5/10, 2 plus 1 and 5/10, 3 plus 1/2, 4 minus 1/2. We see some multiplication, some addition, subtraction. 1/2 times 7, 3 wholes and 1/2, 14/4. Nice. Okay. 2 plus 1/2, 4 3/4, and 1/2. Nice. Okay. Excellent. So you can do this with your class as well, or you could even ask them to share it out, one at a time while you're recording on a poster paper behind you, or however you want to do that. But it gets them to see, once you have all of these populated, it gets them to see that there's a lot of different ways to make up this one number, and if you do have kids that are maybe third graders that have a little bit more solid understanding of multiplication already, they may do some things that other kids don't have as strong a grasp of, and that's going to give them an opportunity to start to think about those answers that are different than their own. And so one of the extensions, the next thing you would want to do is ask students, because I'm going to step back a second. As you're recording, you would want to record anything, even if it's incorrect, kind of like number talks, if you're familiar with that. Because if you do end up with a couple up there that are incorrect, the next step is to ask the students whether or not they agree with all of the solutions that have been proposed. And so this is an excellent way to build number sense with students, because they have to be kind of critical observers of the solutions that their classmates have provided. So in order to do that, they've got to look at each problem and see if it makes sense to them. And they can bring up ones that don't and challenge those and ask some questions about them. The Another way or another extension that I've seen in classrooms that works really well is to choose maybe one of the solutions that a child shared, like this repeated addition of 1/2. Maybe one of those solutions is something that really aligns with what you're teaching at the time. And you could ask the students to take that solution and either with manipulatives or a drawing, draw out what that solution looks like. And to them, maybe they're going to draw out circles and cut them into 7/2, that kind of thing. But that gives them another way to take that abstract idea back to the concrete, and it solidifies it a little bit more for them. They could also do the same thing, or they could identify maybe ones they don't understand as well, so that you can go a little bit further with those solutions if it aligns with what you're working on at the time, or if you want to just do that as an extension activity. So with that, what I want to do is give you an opportunity to take a look at this in breakout rooms. So we do have, I'm going to stop sharing for a moment, and I am going to put into the chat a link for a shared Google slide deck. This isn't the slide deck we're on right now, but it's a bunch of blank slides of how many ways that you're going to have an opportunity with your small group of 4 or 5 to create a how many ways and anticipate what student responses to it might be. So when you get into your breakout rooms, you'll be in there for about 10 minutes, and you'll have, if you're in breakout room 5, then it's going to be on slide 5 and so forth. And then if you're looking for an example, you can scroll all the way down to the bottom of the slide deck. There's an example down at the bottom there. So here's the slide deck link if you want to open that up. And I'm just going to pause chatting for a moment while I create the breakout rooms real fast. All right. And like I said, you'll be in there for about at 10 minutes, you'll get a 30-second warning. So introduce yourselves real quick, decide on, what kind of grade level, what you would like to do as far as the number in the middle, and then anticipate student responses on the sides. And we will automatically assign you to the breakout rooms. And we'll see you back here in about 11 minutes.
You have 88.
All right, welcome back, everybody. So if you didn't have a chance to scroll through some of what the other participants and colleagues created, I love how a lot of, they got really creative, snipping in pictures of fingers and triangles. I love, one person took the number, what was it? Who did 42? Took the number and related 42 back to like 42 centimeters is how many inches. And expanded notation using things like helping kids see that 2 10s and 4 1s for 24. So there's a lot of good ways of doing this. This is really creative stuff, 5 nickels or 1 quarter. A lot of different things that kids may come up with to start to see connections all around just one single number. So it's a really good way, and it's really something that I love this routine because it doesn't take a ton of class time to use. It can be used from TK all the way up through high school, and there's so much more you can do with it, because if this is on a piece of poster paper, you can keep coming back to this for a couple of days and keep asking them for different ways to make, or maybe you go from adding in or maybe from a 10 frame or a rec and rec, and you start talking.
Dennis, you're muted.
You're muted, yeah.
So I said all this cool stuff.
We heard most of it. We heard most of it.
Oh, you did. I wonder what muted me. So was I muted since you guys came back in, or no? Okay. So anyway, I was just talking about some of the other extensions you could do, and that I love the creativity on the slides that you guys created, and all of you have access to these. So you can keep this, make a copy of it if you want, as just to be able to kind of scroll through it as you're going after the session. So we want to look a little bit more at one other routine today, and we want to talk a little bit about estimation activities. So I'm not sure how often you get to include opportunities for kids to estimate in your class, whether it's, before they do a computational problem, you're asking the kids to give you an estimate of what they think it might be, a high or a low estimate, or that kind of thing, so they get an idea, start to build that number sense that's going to tell them, hey, that number's way off. And this number sense is really important, and estimation is a great way to get there, because invariably as kids move through school, they're going to start to use calculators more and more. They may not, they may not all get a grasp of the standard algorithm, but at some point, whether it's during their school, at their years of education, or as an adult, they're going to end up using a calculator, for the mathematics that they may be doing. And one of the reasons why estimation is so important, and number sense in general is so important, is if you put in the wrong thing in a calculator, you're going to get the wrong answer. And we need to know if, like, you miss a digit, like, whoa, wait a second, I was multiplying 42 times 36 and I got 112. Like, I got to know that that's wrong somehow. And maybe I just need to plug it back in, kind of thing. But, without some kind of number sense, our students aren't even going to be able to do simple things like that. So the estimation is a great way to start to build that number sense, because kids start to get a better understanding of the magnitude of numbers and what to expect from multiplying, or what to expect from dividing and addition and subtraction. And then get a chance to compare, like, hey, was I close? How well did I do? And why? So that's kind of the big reasons why estimation is so important. And we wanted to take a moment and take a look at an estimation activity that I pulled off of a website you may be familiar with, Estimation 180. And so the idea here is, in the chat, take a look at this picture. And take an estimate of what you think the height of the tire might be on this tractor. I'm going to stop sharing for 1 second and share my screen a little differently, because I'm not seeing the chat. That's weird. All right. Karen, you're muted, but what are some of the things in the chat?
I was just going to tell you, 5 feet, 5.5 feet, 42 inches, 3 feet, 8 inches, a couple more 5 feet, some 3 feet. We have a 6. I really like that one didn't have anything, because that gives us that idea of, well, 6 what? Is it 6 puppies? Like, let's attend to some precision with that. That's awesome. Those are great conversations and ways to value that thinking, but also ask for clarification. 4.5 feet, all kinds of great answers.
What other information might you find helpful? Because that's another thing you can ask kids to think about too, is with a picture like this, trying to figure out the height. What other information could I give you that might be helpful to help you make a better estimate?
So we have knowing how tall the child is, the age of the boy, how tall is the boy?
Would it help
If
to
I
know the
knew how
size
tall
of the
the kid-
rim? Like, I hadn't thought about that before, but maybe the diameter of the yellow rim that the tire's on. So here's a little hint. This is Andrew Stadell, and that's his boy at 3 feet tall. So now make a revised guess knowing the boy is 3 feet tall.
So we have some answers coming in: 4.5 feet, 5.5 feet, 62 inches, 5 foot, 5 foot, 6 foot, 4.75 feet,
Right on.
5.5, 4.5.
All right. So now the exact answer is right there. You've got a 4 feet 6 inches, or 1.37 meters is the height of that tire. Okay. So knowing this, you could go into deeper conversations with the students about, if the child is 3 feet tall, prior to doing the reveal, you could have more conversations with them about, is the child 3 feet tall? Is he, past halfway? Is he shorter than halfway? And how does that help you to make an estimate about his height? So you can see the website down in the bottom of the picture, estimation180.com. There's over 200 different pictures and reveals like this, as well as lesson planning guides, all for free, that Andrew Stadell has curated, I believe, with a few colleagues. But feel free to check it out. It's a great way to get estimation activities into you. There's a great one that my wife's students always loved, and we've used in other trainings with cheese puffs on a pan. And they talk about, like, they put one on the pan and then how many cheese puffs will it take to cover the whole area of the pan. So there's a lot of different ones on there that are great ways to get into estimation. And you can see with the conversation we had, it's going to take maybe 10 or 15 minutes with students. But the benefit of estimating activities is it bleeds into the other mathematics that you're learning, and that you're teaching and they're learning. So as they get to be better estimators, they're going to get better at a lot of different aspects of the mathematics that you're teaching. And again, this is something that you can do by tweaking the pictures, tweaking the information a little bit, maybe all the way down in TK through 5th grade. So with that, what I was curious to do is just see how you think estimation activities might help build number sense with students. So what I want to do is drop you guys back into your breakout rooms. I'll put you with the same people and just have a conversation about, how do you use estimation activities? If you don't, how do you think they might be helpful? Maybe share out some experiences. I'm hoping some of you have seen Estimation 180, can share what you do, things like that. So I'm going to drop you into your breakout rooms one more time, just to have that conversation about estimating activities and how they can help build number sense. So here we go. If you're still in the main room, you can click on the breakout rooms down at the bottom, and it will take you to, or allow you to join the breakout room you were assigned to. Down along the bottom where the chat is and participants and mute and things like that, there should be a button that either says more and breakout rooms will be in there, or it'll say just breakout rooms.
I don't see that on my side.
I don't see it either.
Okay.
I have more or breakout room.
All right, then
It
let me do
thinks that
this.
I'm waiting to be assigned.
Hello, I don't have it either.
Okay. Seems like a
I don't
few
have it. It
people.
had sent me to 6, but it never let me join. So I just filled in the chart, but I never was able to talk to anyone.
Oh, I'm so sorry for that. Let me add all of you into some other breakout rooms. We'll get you in there for the conversation. There we go. All right, welcome back, everybody. Still a few people coming in. Hope the conversations were useful about estimating activities. What I'd love for you guys to do is, if there was one kind of nugget from your conversation or something that you wanted to share, if you could drop that in the chat right now, just one aha. Maybe we can get somebody from each group, or just if you've got one of your own, put it in the chat. Okay, I'm not sure why that keeps muting me, but I think it's working now. So go ahead and drop that in the chat from your conversation about estimating activities and how those can help build number sense for students. So we're coming to the end here, and I love that. Estimation should include some fun. We're still grappling with how to build students' skills to be able to estimate using reasoning. So that's actually a good point that Ashley brings up in the chat. Is one of the things that is nice that Andrew Stadell and Estimation 180 argue for is for kids to make a too high and too low estimate, because initially they're going to say, like, you know, let's say you're multiplying, or you have a jar of marbles, you know, that has like maybe 100 marbles in it. And some kid's going to estimate, oh, the too high amount is 1 million, you know, and, you know, maybe be prepared with a slightly larger jar or a picture of that jar that you know, and can tell them, well, this jar is bigger, is a little bit bigger, and it only has 500 in it. Because then you can immediately kind of start to narrow that focus of that high estimate and low estimate, because we know kids, they're going to throw out like the biggest number they can think of. And then the lowest estimate is 0. And you can always have that conversation then that, you know, we know there's more than 0 in there. So is that really the lowest it can be? What do you know, that kind of thing. But there's other things in here too in the chat, like there's some neat activities on estimation in U-cubed, showing pictures to students and having them reason about the pictures is a great way to do it, things like that. So hopefully this is something that you're able to incorporate into your routines. Doing a notice and wonder on the estimation activity first works well too. So thank you all for sharing those ideas out. And we're coming to the end here, and just a few key takeaways before we finish up and meet again on November 19th, if you're able to join us then. One of them is going back to what we started out with, just remembering that number sense is something that's caught, not taught. It's something that we're able to help kids grow in with the experiences we provide for them, but it's not something that they're ever going to grasp if we just directly teach to them. So number 2, a strong number sense will help them with every other aspect of mathematics, being able to acquire ideas more quickly and hold on to them more solidly. So the third one is things like number talks, how many ways, estimation activities. There's a lot of different number sense activities out there. What they all have in common is they're eliciting student thinking, and they're getting students to interact in novel ways with numbers. to be able to see relationships between quantities and connections and things like that. Finally, have students explain their thinking. That's crucial. You know, we have to be able to get in there and see what they're thinking to be able to move our instruction forward, but also to be able to question them and deepen their number sense and understanding. And finally, coverage of content to a large degree has to take a backseat to developing number sense with students. Not that we don't need to cover content, we do. You know, we need to prepare them for the next grade, but there is also a mountain of evidence that shows if we cover a little bit less, they actually understand it a little bit deeper and they do better in subsequent years. And we've got to remember that, because when we're pressed for time with pacing guides, especially in our current environment, where, you know, we really have less time than we've ever had before with students. We've got to remember that, you know, if we move too quickly and we go too fast in an effort, you know, to do our best to cover content, we're doing a disservice in many ways to students. So please, you know, take the time that you can take and build that number sense in students deeply so that they can be more successful in acquiring the skills and the knowledge that they're going to be taught in future grades. With that, I do, I'm going to, because you can never see anything that I hold up when I have a virtual background on. So here's the information up on the screen about our next session on November 19th. It's at the same time. And there is a very quick evaluation. But one of the things I wanted to point out is I'm going to pin my video for all of you for a moment and stop sharing my screen. But if any of you are really like the research and ideas behind number sense, there's a wonderful book. It's dense, but it is really good, called it looks like this, and it's called The Number Sense. Oops, I'm covering it up. But it talks about how our brain actually naturally acquires number. But again, it is a research text and it's kind of dense, but I've flipped through pieces of it over the years, and everything I've read out of it is very fascinating, especially in work I do with kinder through second grade, and the way kids naturally acquire numbers and number sense. So with that, the evaluation is here. One thing I wanted to let you know is we'll send out probably tomorrow morning and the evaluation link again, but also the presentation from today. When you do go to the evaluation link, please look for the title in the drop-down menu, Number Sense Routine Session 1, October 27th.